Hi guys, welcome to this video. This video I kind of just want to go through and talk about the different observations that we can make when a chemical reaction happens. So we're talking about things like heat and light, gas produced, color changes, okay, and the formation of precipitates, okay. So I'm just going to go through a bunch of different reactions to try and show you as many of those as possible, and I'll kind of talk through as I go kind of different observations and stuff. Okay, so I'm going to start here. I've got a test tube. So first thing I'm going to do is I've got some potassium iodide here. Okay, so you can kind of see, right, it's a clear colorless solution. Okay, so we call it colorless in chemistry. Okay, so I'm going to put a bit of that in my test tube here, like so. Okay, put that off to my side, and then here I've got some lead nitrate. As you can see, also a colorless solution. Okay, and we're going to drop that in there, and we'll see what happens. And there we go. Okay, and so what I've got is I've got a color solution plus color solution has got me a bright yellow precipitate. Okay, it's precipitate. You'll see, and I'll show you later again after we've done a few more, but there's solid material down in the bottom of that test tube, and that will settle out, and that bright yellow precipitate is lead iodide. Okay, so the sodium, or whatever do we have? No, potassium nitrate will still be floating around in the solution, and then that precipitate, I'm not sure if you can see it on camera, is starting to settle out, but we'll have a little bit of a look at that later. Okay, so that one sort of covers two, right, of our observations. Okay, so we had a precipitate formed. Okay, precipitate is basically something that's solid, solidified, becomes a solid, comes out of solution and into a precipitate. Okay, and obviously we had a color change there. We had two colorless solutions made a bright yellow precipitate. So that's kind of cool. Okay, next up we're going to have a little bit of a look at some gas formation. Okay, so in here I got some potassium carbonate. Okay, and carbonates love to degrade. I'm just going to pour that all in there into carbon dioxide. Okay, so here I've got some hydrochloric acid. So again, all right, colorless solution. We'll bring that up nice and close, and you'll be able to see some gases forming in there. There we go, that's a better one. Okay, so you can see all those bubbles, all of that is carbon dioxide gas. There we go, forming in there beautifully. Yeah, so so it kind of looks a little bit like when I'm doing this, like a soft drink. Okay, similar sort of thing actually happens in a soft drink. You've got carbonic acid under pressure, so it stays carbonic acid, but it doesn't. Carbonic acid is not very stable. Okay, and so as soon as you release that pressure on your fizzy drink, the carbonic acid degrades into water and carbon dioxide. Okay, and you get all the fizz coming off your drink, or coming out of your drink. Okay, the next one I'm going to do, right, this is kind of a two-stage reaction. I'm going to make a complex ion. So I'm going to take some copper sulfate. Okay, so you can see there, it's a blue solution. It's clear, I can see through it, but it's blue. Okay, so a clear blue solution would be the observation I make there. Okay, I'm going to drop some of that into my test tube. Okay, now what I've got here is I've got some concentrated ammonium hydroxide. Okay, it smells like toilet cleaner because ammonium hydroxide is essentially toilet cleaner. Okay, so I'm going to take that. I got it in a, and I'm just going to put a little bit to start off with in my test tube. Okay, so I'm going to put that in there. Right, and what you'll see is I kind of, you kind of missed it. Let me just put another drop in there. Okay, is I get a bit of a precipitate going on there. Might be a little bit hard to see. I'll try and just got to do this a little bit at a time. Okay, you can kind of see it. There we go. Here's a good one. Okay, there we go. We got a precipitate forming in there. Okay, do a little bit more. See if we can get a little bit better. Yeah, there we go. Okay, so we've got a good precipitate forming in there. Okay, what I'm going to do now is I'm going to make a complex ion, which you'll learn about later. But I'm going to dissolve this precipitate and I'm going to make something new by adding more ammonium hydroxide. So I'm going to add quite a bit more. Right. Kind of makes this jelly precipitate. Going to keep adding it until I'm satisfied. Right, and you can probably start to see we've got a colour change going on here in my special swirl technique. Yeah. It's not really working because this is actually kind of, oh, here we go. So it's kind of cool. You can kind of see the two different stages. Yes, I got my copper sulfate here. I've got my precipitate, kind of ammonium precipitate coming on here. And now this is my complex ion, which we'll learn about another stage. But you can see there's quite a stark color change going on there. So we formed a precipitate and we're actually dissolving that precipitate to create this complex ion up here, which is this kind of cool blue. So let's see if I can get the whole thing to go. I don't think I can because I think my precipitate's kind of going in the way, but it's kind of cool. You can kind of see the three different stages of what's going on there. So that's pretty cool. And you can see again, we got significant, if we get out our original, right, significant color change. Right, this blue and this blue are very different. Okay, and this was our colorless solution as well. So again, very different. So definitely chemical reaction happening in there. Okay, the next thing we're going to do is quite a cool one. Okay, so in here, right, I'm just going to bring my camera angle down. Okay, in here, okay, I've just got sugar like you would find in your house. You know, put in your coffee or your tea or whatever. Put in your baking. Okay, good old plain sugar. And I put these gloves on because I'm working with super concentrated sulfuric acid. Okay, so normal sulfuric acid we kind of find in the lab is 1 mole per litre. Okay, so you guys know what a mole is. Okay, and then the kind of concentrated, or the stuff, you know, if we're looking at getting some high-powered sulfuric acid, is normally about 6 moles per litre. Okay, this is 18 moles per litre, and it has an almost oil-like consistency. So what I'm going to do is pour this into the sugar here, and what's going to happen is sulfuric acid is a dehydrating agent, so sugar is a carbohydrate or hydrated carbon. Okay, so it's got a bunch of hydrogens and oxygens attached to carbon rings, and this stuff is such a dehydrating agent it's going to rip those off, and we will see a cool reaction hopefully. This, if I've got my measurements correct. It just takes a little bit to get started, so we're just going to have to kind of wait a little bit. Just going to give it a little bit of stir just to make sure that we got it all happening nicely there. So what you can see coming off here is a lot of steam, so it's exothermic reaction. We're producing a lot of heat, okay, and it smells a lot like burnt marshmallows, okay, but we can definitely see it definitely got some heat coming, okay, and yeah, it smells like burnt marshmallows. So it just took a little bit of time there, obviously, to get nice and warm. Okay, but again, right, you can see, because I spilled sugar everywhere, right, the original color of the sugar was this white, okay, and now we have black, and we've got heat coming off, and what you can see, that smoke is steam, okay, and probably a little bit of burnt carbon as well. But yeah, that's quite cool, okay. That one didn't quite work as well as my practice one, so here's my practice one, right, which made this cool tube. This one doesn't quite look as funky. Don't breathe in those fumes, there's a bit of acid in there as well. But yeah, so that's quite cool, and that's solid, and you can, it's quite hard to probably see on camera, but there's lots of air bubbles and stuff in there. Okay, I'm just going to put on my gloves. Whew. What I'm going to do, right, move that out of the way, is I'm going to react some sodium. Okay, so some potassium metal, actually, I believe it is. Okay, so I got water. Okay, I'm going to put a little bit of phenolphthalein indicator in here. So this indicator is colorless, as you can see as I drop it in there. Okay, it's colorless. It's got no color, you can't see it, but it will turn pink when it goes basic. Okay, basically when there's a whole lot of hydroxide ions. Okay, so in this jar, right, I have oil and I have some potassium. Now potassium is a very reactive metal. You can't find it in nature. Okay, if we expose it to air, it oxidizes very quickly, even under this oil coating. Okay, you will see, if I can get a piece out, I'll show you, be very careful here. Okay, so it's covered in oil, and you can see it's all white, so it's all oxidized currently. Now, just put it on a piece of paper here. Now if I cut this, okay, potassium and a lot of the group 1 metals are very soft, so I can just cut that, and if I'm quick enough, you'll be able to see in the camera the shininess of the metal. Now if I dropped all of that in the water, I would get quite a big reaction, and it'll be quite dangerous. So I'm just going to take a little piece and put the rest of this back under the oil, okay, because I don't want that reacting. Put that lid on nice and tight. I'm going to put that away. So even this piece I feel might be a little bit too big to kick off with. Okay, so I'm going to drop a little piece here. Might be really hard to see in the camera, but I got a tiny piece there. Got my beaker with water, okay, and I drop it in, and I'm going to take a few steps back because I got new shorts on that my wife just bought me, and if I get potassium hydroxide on it, she's not going to be impressed. So I'm going to drop this in here, and then if I can, there we go. So you can see the water's changing colour. I'm producing some potassium hydroxide. The metal is kind of scooting around on the top, okay, and it actually, when I did this for practice, it exploded on me. So I got a slightly bigger piece here, okay, so we'll do the same again, right, but you'll see it kind of scoot along the top, it fizzes, so it's producing hydrogen gas and potassium hydroxide in the water. So let's see if we can get one to pop. Okay, so it's not exploding like it did for me when I did a practice. We'll just try and I'll grab one more piece. We'll cut another piece up and we'll see if we can. I don't want to go too big because I don't want to, blow myself up. So basically, what happens is it produces so much heat that the hydrogen gas that it produces. So this one's kind of cool because it does a whole lot of things. You got heat. We'll get sound if we get this right. We've got gas produced. Right, we've got a colour change because of our indicator. So. Okay, but hopefully you guys saw how we got different color changes, we got heat produced, okay. A couple of times we got sparks, we didn't quite get the light that I was hoping for, but you kind of get an idea of all those different chemical or observations around chemical reactions. We've got color changes, we've got precipitates, we've got gas produced, and we've got heat and light changes. Heat and light and sound. Sometimes sound as well. Okay, hopefully that was helpful. That was fun from my part. I'll see you guys later.